Okay, picture this, an AI that can not only mimic your voice perfectly, but can then turn around and compose an entire symphony. I know, it sounds like something straight out of a sci-fi movie, but we're looking at a breakthrough today that's trying to do just that. Master the whole world of sound, from talking to music, all inside one single AI model. This is a massive leap forward, and we're going to break down exactly how they pulled it off. So, let's start with that big question. What if one AI could really, truly master both speech and music? On the surface, it seems pretty simple, right? It's all just sound waves. But to an AI, they are completely different languages. Human speech is all about crystal clear precision. Get one tiny sound wrong, and you change the meaning of everything. Music, though, that's all about feeling, harmony, rhythm. For the longest time, teaching an AI to do both at once was, well, kind of like trying to teach a fish to climb a tree. It just wasn't going to happen.
And that's where we hit a massive wall, a problem that researchers call the audio divide. See, it turns out you can't just throw a bunch of speech data and music data into one AI and hope for the best. In fact, when you try to do that, the results are usually a total disaster. Let's dig into the two huge reasons why.
So the first big roadblock is something called task conflict. Think of it like a tug of war inside the AI's brain. For speech, its number one job is clarity, making sure it's understood and sounds like a specific person. But for music, the goal is totally different. It's all about creating beautiful melodies and rhythms. So what happens is, every time the AI gets a little better at music, its speech starts to sound all jumbled and robotic. And when it gets better at speech, its music falls flat. The two goals are literally at war with each other. And if that wasn't enough, there's another major problem: a massive, severe data imbalance. Just think about it. We have endless libraries of high-quality speech data. Audiobooks, podcasts, you name it. But finding that same amount of high-quality, perfectly labeled music data, it's so much harder to come by. So when you train an AI on this lopsided diet, it just gets completely overwhelmed by all the speech. It becomes an absolute expert at talking, but when it comes to music, it's basically tone deaf.
So how in the world do you solve a problem like that? Well, this is where things get really cool. Researchers came up with this brilliant new architecture called UniMoE-Audio. And the big idea here isn't to build one single super genius AI. Nope, the secret is to build a highly effective team of AI specialists. This whole approach is based on an architecture called a mixture of experts, or MOE for short. Instead of having one overworked AI trying to juggle everything, you create a team. You've got your speech expert over here, your music expert over there. When a job comes in, say generating a sentence, the system routes it to the speech specialist. If it's a melody, it goes to the music specialist. It's such a clever way to get around that whole task conflict, tug-of-war we were just talking about.
And this AI team has three kinds of players. First, you've got your routed experts. These are the hardcore specialists, like a linguist for speech or a composer for music. Then you've got your shared experts. These guys are the generalists, handling the basic building blocks of all sound, things like pitch and tone that are common to both. And then there's my favorite part, the null experts. This is an absolutely brilliant efficiency hack. They look at the incoming sound, and if it's super simple, they basically say, hey, we got this, no need to fire up the big guns. It saves a ton of computing power.
But you know, a team is nothing without a good manager, right? And that's where the smart router comes in. Now, older systems used to just throw a fixed number of experts at every single problem, which is really inefficient. This new manager is dynamic. It actually analyzes each little piece of sound and decides exactly how many experts are needed. So a simple word might just need one or two specialists, but a really complex musical chord, the router can call in the whole team. It's an incredibly smart way to manage the AI's resources. Okay, so you built your AI A-team. The architecture is brilliant. But remember that huge data imbalance problem? A great structure is totally useless if you don't have a smart way to train it. So how do you actually teach this team to work together without the speech experts just drowning everyone else out? Well, the answer is a really clever three-stage training process.
You can really think of this training curriculum like a school program. First, every expert goes off to their own individual school to become a specialist. Then they all get together for a team warm-up to figure out how to work together. And finally, they all collaborate on the big project. And this process is the absolute key to solving the data problem. In stage 1, each expert trains alone on its own huge dataset. The speech expert sees tons of speech, the music expert sees tons of music. There's zero interference. Then in stage 2, they bring the team together, but, and this is critical, they only train the manager, the router, on a small, perfectly balanced dataset. This teaches the manager how to delegate tasks fairly. And then finally, in stage 3, the whole team trains together to fine-tune everything and really learn that synergy.
Now, all of this sounds amazing in theory, but the big question is always, does it actually work in the real world? Well, the results are in, and honestly, the payoff is pretty incredible. Let's actually look at the numbers.
This chart right here tells the whole story. On the left, you've got your specialist models, AIs trained on just one thing, and yeah, they do a good job. In the middle, that's the old, naive way of just mixing all the data together. Look at that. Performance totally tanks. It's a disaster. But then look at the bar on the right. That's UniMoE-Audio. It doesn't just avoid the collapse, it actually performs better than the dedicated specialists. It's a true synergistic gain. The team really is greater than the sum of its parts.
And when you dig into the details, the wins are just so impressive. For speech, it hits top-tier, state-of-the-art performance. But get this, it does so with up to 30 times less data than its rivals. That's huge. It could mean way more realistic and accessible voice assistants, or even new tools for people with speech impairments. And for music, it's not just about hitting the right notes. It excels in aesthetic quality, creating music that's genuinely richer and more enjoyable to listen to. This is an AI that's starting to understand not just the science of music, but the art.
Just as the researchers themselves put it, this new approach has unlocked substantial potential for the future. This isn't just a small step forward. This is basically a new blueprint for how to build AIs that can understand and create across totally different, really complicated fields.
And that leaves us with a really fascinating thought to end on. We've just seen an AI master two of the most deeply human languages there are, speech and music. So, what comes next? Could a model like this learn to interpret the sounds of the natural world, like the weather or the ocean? Could it even help us finally understand animal communication? The frontier for a truly universal audio AI is just opening up, and we're only beginning to hear what it has to say.